it. So, like before starting, let me also introduce myself to those who are new. I am Sarthak Srivastav. I am working as a brain AI researcher at WorldQuant. So, yeah, I hope you can see my screen, right? Yeah, it is visible. So, the agenda for this session is first of all, we will see why Python out of all the other programming languages. Then we will set up Python, and along with Python, we will use a IDE called VS Code, and we'll also set up Jupyter Notebook. Then we'll start with basics of Python like a hello world script, variables, data types, basic arithmetic operations, then conditionals and loops, and then some data structures, then functions, basic exception handling, some files read and write tools. Uh, we'll learn about JSON as well in very brief, and then cover the API parts. So first of all, let's see why Python. I assume that a lot of you have already worked with Python before, but to just refresh your memory, so Python is a like very readable and close to English language. It is very easy to learn. It has a lot of batteries included. By batteries here, I mean it has a very standard, like huge standard library of its own. It has a very massive ecosystem of supporting libraries or modules which you can use in your workflows. For example, NumPy, Pandas, scikit-learn, etc. These days, the default language of data AI ML is Python. So most of the quant research, AI research, uh, model development, and AI tool development is also done in Python. Apart from that, it the Python has first class AI tool support. So all the like cutting edge LLMs like ChatGPT, Claude, Go, GitHub Copilot, etc., all can generate excellent code in Python. So you can describe your idea in English and you can get the working code very immediately. uh, Other than that, the very important point is the WorldQuant Brains Python ASLib lets you simulate, fetch data, and automate the alpha workflows in Python only. So like it is very glue language. It can easily talk to other APIs, databases, files. You can basically easily integrate Python with other tools or other libraries and other languages as well. So let us first see how to install Python on your local machine, along with IDE called VS Code. So like for those who are using Windows or Mac, they can just directly go to this website, python.org/downloads. So let's do this right away. Or you can just simply Google search, uh, and you will pop up with Python download page. So here it is. So here you can go and get the latest version of Python, right? So you can install. I am downloading the Python file. You can do it along with me on your machine. So I am opening this. The download is complete. The file is opening. Although it is already installed on my machine, but just to show you how it works, I am running it. So you will see this dialog box, and yeah, you will see this dialog box, and you can choose this option, add python.exe to your path. This is very important because if you don't add python.exe to your path variables, environment variables, you will not able to see Python in the recommended Python environments when you will run it in your terminal or in the VS Code. So please make sure that you mark this check, add python.exe to path, and then simply click on install now. So this is very easy to do. Once you install it, the Python will be installed on your local machine. You can verify it by going to terminal. Like you can go to your terminal, you can go to CMD and write Python here. Not on this one. Okay, let me show you my VS Code only. Yeah, so you can simply go to terminal, any terminal like on your machine, and just write Python. So once you write Python, you will see Python REPL will launch, and here you can write any code. For example, print uh, hello world. So this will let you write any Python code that you want. But the thing is that this style of writing code in terminal is not very interactive, is not very feature rich. So to make our ecosystem very feature rich, we will install a tool called IDE, Integrated Development Environment. You can like choose any IDE of your choice, like VS Code, like PyCharm or Sublime Text as a code editor. So let's move to that step. So I'm assuming that you have installed Python on your local machine by now, right? The next is to install VS Code on your machine. So to install VS Code, you can go to the code.visualstudio.com website and just download it from there. It is again very easy to do. So I am just canceling it because it is already installed my machine. And I will go to, like, again I will search VS Code download. So VS Code is an very lightweight IDE and code editor. So it becomes a full-fledged IDE when you install extensions into it, right? So yeah, this is a download page for VS Code. If you are on Windows, you can download it from here. If you are using Linux, you can use these two options. If you are on Mac, you can use the Mac option to download the VS Code. So since I am on Windows machine, I will choose this Windows option and it will start the download. So yeah, download is started and I can open the setup. So the setup is downloading and yeah, it will open in some time. So till then, let's see if you yourself have downloaded this so far or not. So yeah, one question like from Harsh is Python is slow. Isn't C++ suitable for quants? So it depends. If you are working on data, if you are doing some data processing and data manipulation, data transformation using some machine learning tools, Python is a good option, is a very good option because of the availability of libraries like NumPy, Python, NumPy or Pandas, etc. Other than that, the main usage of C++ in quant domain is for simulations or to make the code more closer to hardware in very simple terms, if I say, so that you can run the simulations on very large data sets very quickly. Yeah, so the VS Code has now downloaded and we can run the installer. So once you run the installer, so yeah, so since it is already installed on my machine, so let's see if I choose this no page, no option. Yeah, because it is already there, but you can easily follow the steps to download this on your machine. And once you download the VS Code, you will end up on this page. Like this is the first page you will see in VS Code. So what you have to do when you set up VS Code is you have to install some extensions to make your life a little easier while working with Python and Jupyter notebooks, right? So to install the basic extensions, let me show you what those extensions are. So first of all, search for Python. So Python extension is already installed in my VS Code, but I'm showing you. Yeah, so this is the one. So if you see Python, this Python package, this is from Microsoft. This is the official Python extension for VS Code. There are other extensions called Python, but they are not official. So I will recommend you to use this one only. So once you install this one, it will come with the extension pack. It along with Python, it will also contain Pylance. It is a LSP for Python. It will also contain Python debugger and Python environments. So I assume like that you will install all of these extensions on your VS Code. So this is the first one. The other one is Jupyter extension. Yeah, so this one is the Jupyter extension, and it again is coming from officially from Microsoft, and it is also an extension pack. It contains 4 extensions called Jupyter Key Map, Jupyter Notebook Renderers, Jupyter Slideshow, and Jupyter Cell Tags. So make sure that you install these 2 extensions on your VS Code to make the code run and to make uh, the use of most of the features that are available in these extensions while you run your Python code, right? So are you with me so far? Is this clear, like how to install Python and how to install VS Code? Great, great. So let's move to the next part. Once you have installed the Python extension and Jupyter extension, you can just simply check in your terminal, like I showed. By running Python command, you will load the Python REPL, where you can try running any code, right? So the first step, so create a folder for your experiments and for your automation file that you will create. So you can either create a folder using these commands mkdir, or using the UI based tool on any OS like Windows, where you can simply create a new folder. Just get into that. To open that folder in VS Code, what you need to do is go to Files option, then click Open Folder. Right? You have to click this Open Folder, then choose the folder that you created from here. Right? So this way you can open the folder that you created. Then one recommendation when you run your Python code is to create a virtual environment. Why? Because when you make multiple projects, they may use different dependencies. So, and you don't want your different development environments to get messed up and or be very cohesive. So I would recommend to create virtual environments in your Python project and install the dependencies that are required. You don't need every library there in your environment, right? So it says, like, it is very very easy. Just run this command python -m venv. So python -m venv is the command to create the environment variable, the virtual environment, and .venv is the name of your virtual environment. So you can give it any name like brain env. Then once your environment is created, to activate that virtual environment, you can use these commands. If you are in Windows, you can use this command .venv/script/activate. If you are in Mac or Linux, you have to use this command source space .venv bin activate, right? If you don't want to create a Python environment this way, what you can do is you can press, once you are in VS Code, you can press Control Shift P. Control Shift P, I am repeating again, Control Shift P to open this command palette. The other way to open this command palette is go to settings option. Then here you will see command palette. Control Shift P is the shortcut for this. Here you can write create virtual environment. So yeah, create environment. This one. So Python create environment is there. So you can use this option as well to create a virtual environment. So both options are available, right? So once you create your virtual environment, then create a notebook file with the extension .ipyenv, like I created right now. So this is like Python webinar basics.ipynb. You can simply click here to create a new file called xyz.ipynb, and a Python notebook will be created like this, right? So you can create a Python notebook on your own. Then once you create a Python notebook, try running this command or this hello world code, right? Uh, for example, I am just printing this hello world quant brain in a cell. Uh, to run the cell, either you can use this button here to run the cell, or you can use or you can use shift plus enter shortcut. So I'm using shift plus enter to run this, and this is printed. Now, many of you might occur into an error that Python is not found or something like that. So to make sure that your Python is found or your environment is used, go to this option here. So to choose the Python interpreter, like, right? Here you will see Python environment, Jupyter kernel, Jupyter server. So use any of that. So in your case, there will be Python environments. And for example, in my machine, these are the Python environments that are available. So I will choose any of these, whichever has the required dependencies installed. So I'm already into one of my Python environments, so I will use it. So let me know if you can run the hello world Python file. Great. So I can see a lot of thumbs up. So that means you are able to follow till this step. Great. So one more thing, you can add a comment by starting it with a hash. So any line that contains hash at the starting, Python ignores it, and they are for humans to read. So you can write multiple comments, and then again you can create multiple lines that has comments, then a line that is able to be run. Then we create, for example, this Python basics. Now let's move to the next topic, which is variables and data types. So variables is a name that points to a value. It is basically a like it provides a placeholder to store some data, right? So to store some data or some value. In Python, you don't need to declare the type of that variable. For example, in C++, we have to define, right, or declare what is the type of data type of this variable. But in Python, you don't need to define that. Python automatically figures it out once you define the value. Based on it, it figures it out what is the type of data. So here is an example. For example, we created some variables called name, age, sharp, is live, nothing, right? So for example, name is a text which is called string in programming world. So in programming world, we store text in the form of strings, which is uh, written inside double or single quotes. Then we have age. It is a int data type. So int can be a whole number or negative number or anything. Then the sharp. Sharp is a variable that contains float type of value, which is 1.85. Then we have boolean. Boolean is either true or false. Only two values are possible for boolean. So is live set as true. Then there is one more data type, which is none type. When there is no value present, you use none type. So in nothing, we have stored none type. Then we can try printing it and see their types as well. So you can see we have printed the name, age, sharp a, is live, a boolean, and then none or nothing, and also printed the data types of all these variables. Then one more thing about variables is you can reassign these variables to different data types. For example, here we have assigned x to 10. Then we can print, we will see what is the output of type of x. Then we will assign the x to a string, and the data type should change. So if we can see, earlier it was printed as 10 and the data type was int. Then it changed to string, and the output was now a string. Then we can do arithmetic operations in Python. We can use add or using a plus sign, minus using a minus and using for subtraction, then asterisk to multiply, slash to divide, double slash to floor divide, then modulo, and then power. Power is basically the exponent. So all of you like have seen all these operations in your calculator. You can follow the like same, and Python also follows the same order of board mass. And here is an example. If you want to see, there are two numbers a and b we have defined, and let's see all the arithmetic operations on a and b. So here it is. Here's the output. We can see the sum, the difference, the product of a and b, the division, etc. Then a very small example, if you want to calculate the return percentage. You know the buy price and you know the sell price. So how do you calculate the return percentage? You subtract the sell, like buy price, from sell price and divide it by the buy price, and to get the percentage you multiply it with 100. So we can run this example. Just it is a very basic example to understand the arithmetic operations. So we can see the output is 8.5%. Then the next topic is strings and f strings. So as we just discussed, strings are used to store text. You can use double or single quotes to define a string, and we also use f strings. So these are a modern way to uh, create strings in which you can inject variables. So f strings are formatted strings. Uh, so as we can see in this example, we created three variables: region, universe, and sharp. Region and universe are string, and sharp is a float value. Then we created a f string to put in the region and universe using variables as well as sharp. And then you can format this string using either f string, or you can use the older method of dot format. This is a dot format based approach where you can format your string. And then there are some basic and useful string methods that should uh, like you must know those methods. So first one is to strip a string. It removes the white spaces at the extremes of the string. You can chain multiple methods. For example, we have chained dot strip and then dot upper. So dot strip will clear the white spaces, and then dot upper will convert it to uppercase. You can use in operator to check if a substring is a part of a string or not. For example, we are checking if close is in this expression or not. We can run it to see what is the output. Yes. So the print message output is alpha tested on USA top 3000, then sharp 1.86, right? Now you can ask me the float contained 4 decimal points and this output is containing only 2 decimal points. That is because we have rounded off it to 2 decimal points using .2f method. So then then using string form dot format method, the region equal to USA and sharp is printed. Then if we strip, so in the next example there are some white spaces, as you can see, before and after the alpha expression. So using expression dot strip, we have removed the white spaces. Then using so we have removed the white spaces in this one. Then using chaining methods, you can see the output contains the uppercase letters, and in the end we have checked if close in expressions or not. So this is coming out to be true. Then the next part is conditionals. So we use conditional to make decisions in Python, and in conditionals you will also see there is a change in syntax. We are using some white spaces here, so these are called indentations. So indentations are very important in Python. It is a part of syntax. If you make your indentation incorrect, for example this, your code will not run. So you will see an indentation error, right? So so these are some conditionals. So conditionals will tell you, you will use the if statement to make the program take decisions based on some condition. So for example, we like define some sharp as 1.8, and we mentioned three conditions. If sharp is greater than 2, the rating of that alpha could be excellent. If sharp is greater than equal to 1.58, it is submittable. uh, Else if sharp is greater than equal to 1, the performance is promising. Else the alpha is weak. So we can run this example and see, uh, if our sharp is 1.8, it is falling in this criteria, so the output is submittable. Now if I change the value to, let's say, 0.7, the alpha is weak based on sharp. You can use these operators to compare the quantities. For example, we are comparing turnover and like turnover with a threshold, and also fitness with some value. So you can use the logical operators and if else to make decisions based on the condition. I hope so far you are good. I can see, a lot of hands. So great. Okay. So let's move to the next topic, which is loops. We use loops to iterate over a sequence of values, right? So there are two types of loops in Python: a for loop and a while loop. So a for loop will repeat the same code once for every item in that sequence. That sequence could be anything. It could be characters in a string, or it could be items in a list. So for example, if we define a list with the variable name fields, and it contains four values: open, close, volume, and vwap. So if we loop in on all of these fields and try to print it, so we can see, so the output, the testing field, and f is the iterator. So it is iterating over close, then open, then volume, then vwap. So you can see, if we want to repeat some step on a sequence, you can use for loops. For example, if you want to generate numbers in the range 5, so it is basically in the range 0 to 5. You can do this. Then you can use range function. So yeah, if I hover over it, so range function, you can see three parameters: start, stop, and step. So start is the point where the loop will start. The stop is the stopping point for the loop, and step is the number of steps it will jump to reach the end or the stop point. So if I run this cell, you can see the output. For the first for loop, we can see numbers from 0 to 4 are print. For range 5 function, why 5 is not printed? Because the stop is always excluded when you use range function. And same here, if we are iterating on from 2 to 10 with step 2, you will see the output as 2, 4, 6, 8, not 10, again because of the same reason, because the stop is not included in the for loop. Then there is a while loop. So while loop runs based on a condition, and it runs until the condition is false, right? So it will only run whenever the condition is true, and will stop once the condition is false. So in this example, you can see we have defined a variable called tries as 0 for, like, we are doing some retries kind of thing, and it will run until the number of tries is less than 3. It will try to make some attempts and then print done. So we can run this, and you can see it ran for 3 times until the value of tries is 3, and once it was 3, the condition of tries less than 3 becomes false because try is equal to 3. So it comes out of the loop, and then it prints done. So this is while loop. So a key point is, you use for loops when you know how many times you have to iterate, and you use while loops when you have a condition and don't know how many steps will be there to reach the stop. So in that case, you define the condition and then you use while loop until the condition is false. Then you can use nested loops when you have a grid of combinations. So it is a very common use case in alpha research when we try to uh, find or fit our alpha on multiple fields and look back pair. So for example, it is a loop inside a loop, right? So you can try multiple combinations using one loop only. So for example, we defined two variables, fields and lookbacks, and both of them are lists. So you can see first one is a list of strings and second is a list of ints. We defined our count as 0, and we ran two for loops. So we are iterating over all the fields, and then we are iterating over all the lookbacks. And we have this expression f, and we are using f string here, like, pay attention over this. So we are uh, putting these fields and lookbacks in our template, and trying to generate multiple combinations or multiple expressions. So I'm not printing all the expressions. If you want to print all the expressions, we can do that as well. So let's say print expression also. And other than that, we can see the count for that. So if we print this, you can see it has generated all the combinations you in this template by filling in close with corresponding lookbacks, then volume with corresponding lookbacks, and vwap with corresponding lookbacks. So ultimately there will be 3 into 3, 9 combinations. So yeah, as you can see here, so there are all 9 combinations we built. Then you can break the for loop or a while loop based on some condition as well, or you can skip any iteration using continue statement. So in this example, we can see n is iterating over the range of 10. So we want to skip the iteration when n is 3, and we want to break the loop entirely when the n becomes 7. So if we run this, you will see the output as 0 1 2 3 4 5 0 1 2 4 5 6. 3 is missing because we skipped it in this condition by using continue statement, and we use break statement to exit the loop when this condition was met, that is n is equal to 7. Then the next topic is data structure. So we are covering some basic data structures like list, set, and dict. There are many other data structures, for example, stack, queue, etc. But we are not covering in this basic Python series. So in the lists, so basically lists are a data structure where you can put in multiple values in order. You can put duplicates in the list as well, and the list is a mutable data structure. So mutable means you can change the values of items in the list. So we have defined a list named alphas, where we have defined 3 strings, alpha 1, alpha 2, and alpha 3. We can make a list of different type of data types as well. For example, if I create one more item here, 45, which is a list of string and int. So that is also possible. But for this example, we are keeping only string as a data type for our items in this list. So to access the element, the first element in the list, we can access it from the index. So the in first index of every list is 0 up to the length of list minus 1. To access the last element, you can use minus 1 inside the inside the square brackets. To slice a string, you can define the start and end, and you can print the length of strings using len function. Then there are some functions like or methods like append or remove that you can apply on list to add some item at the end, or remove some item from the list. And there are some built-in functions, arithmetic functions like sum, min, max, or average. You can calculate average by uh, computing the sum and then dividing it by the length of the returns. So if we run this, you can see if I access the 0th element, I get alpha 1, which is the first element of the list. If I access the minus 1th index, which is the last element, that is alpha 3. If I slice this list in from 0 to 2, so then we will get the item at the index 0 and index 1. The end again will be excluded. So we got the item alpha 1 and alpha 2. Then the length is printed, which is 3. Then we can append some more items to our list using append method, uh, which is like this, alpha 4. And we can remove any item. For example, we have removed alpha 2, so the output becomes alpha 1, alpha 3, and alpha 4. Alpha 2 is removed. We can also see the sum, min, max, and average of the returns list, which is output here. So this is how we can work with lists. So it is very useful way to store data, because whenever you are trying to work with a lot of data fields or a lot of lookbacks or parameters, and want to create your multiple combinations using them on some template, you can use lists. Then there is set. So set is a unordered data structure which contains only unique values. So it is similar to a set in maths, a unique so which contain only unique values. So it is very useful when you want to deduplicate things. So for example, you are creating some templates and you encounter that a lot of expressions are being created again and again. So in that case, you will end up running multiple simulations for one expression. So you can use set in that case to deduplicate the expressions. So to define a set, like we created a set with variable named tested, and to create a set, you use this function set method, set function. And to add items in the set, you use add method, and then define a value, and then you can print the set which will show the all the items in the set. You can also check if the item is present in set or not. So you do this with in statement. Then if you want to deduplicate a list quickly, you can use sets again. For example, in the raw list, we have defined open 2 times, right? So if you create a set out of this list, you can find the unique outcomes only. If I run this, you will see alpha 2, alpha 1. Now you can see why it is alpha 2 and alpha 1, because it is unordered. So the order might change. The order in which you added the items might change. Then you can check, yeah. So if alpha 1 is present in tested, the output is true. Let's say if I write alpha 10, the output will be false because alpha 10 is not there in the set. Then the unique values in this raw were only close, open, and volume. The close was repeated twice, and open was also repeated twice. So if I print the unique ones, so only the unique ones are open, close, and volume. So that's how you can use sets in your workflow. And then comes a very important data structure called dict. So Python dicts are hash maps. So this is a data structure in which you can store key value mappings. It is like a JSON object, and most of the APIs and configs will come as dicts as a key value pair. Uh, it is like a lookup table. You can assume it as a lookup table. You can search for the key and you get the value. So for example, if you define alpha config, for example, the region is USA, universe is top 3000, then delay, decay, and utilization, you can create an alpha config which is of which data type? It is a dict. As you can see, it is a dict of string, and the values are string or int, because we have used two types of two data types here. One is string and one is int. So to access the keys or any values, we can use we can define that key in string in squared brackets to access the values. You can also use get function uh, to access any key in this. Now this is a safe access, because if I, let's try this. If I run this, and if I do the same thing here again, print alpha config and truncation, we will end up with an error, right? Because this, you can see a key error here because this key is not found in this dictionary. So this is when you use a get method, it is a safe method, because if the key is not found, it will return a default value, that is 0.08. Okay, so we can run it again and see the output. So you can see we have accessed the region. We can access a key that is not present, uh, but it will return the default value. You can see the documentation of get method here. So it is a key. It asks for a key and also default value. Then you can add or update the keys in or values in your dictionary by using the same syntax. You can define the truncation key and assign it a value. You can iterate over dictionary using loop. In the loop, you can use key and value as iterator on this alpha config.item. So alpha config.items will return a list of keys and values, right? So we can use this as well. So it has printed our keys and as well as the values. Then the next is comprehensions. It is very cool Pythonic shortcuts. So it is a way to write Pythonic code in a very short way. For example, you have defined uh, a list, for example, fields and look back here, and you want to create expressions. So earlier we saw we wrote a for loop, right? Here, if you remember, we wrote this for loop, right, to create all the expressions by filling in these fields and lookbacks in this template. But you can do it very quickly and easily in one line using list comprehension. So list comprehension is a way to reduce the loops, the whole for loop into one line. So you can create a list comprehension by starting with the square brackets, and inside that you define some task. For example, we are creating a f string for f in fields, for d in loopbacks. So we are defining two for loops here, for f in fields and for d in loopbacks. So this is very uh, readable, like you are doing this for field, for f in fields and for d in loopbacks. So this way you can create a list of all the expressions using list comprehension. If you want to apply a filter, you can do that as well. So we have created a filter here if the d is less than equal to 10. So if the lookback is less than equal to 10, only then this will run. So this is also done in one line only. Then you can create a dict comprehension as well. For example, if we want to create a dict of numbers to their squares, we can define it like this. So n here becomes our key, and n into n becomes the value for n in range 1 to 6. So if I run this, you can see the output. So in the first case, we created 12 expressions because there were 4 fields and 3 lookback values. So it has created 12 expressions, and here is the output for all of them. We are printing the first 5 ones. Okay, and then we created short only uh, short lookback only expressions using this list comprehension. This is also printed here. And then at the last, we have squares dictionary. So 1 is mapped to 1, 2 is mapped to 4, 3 to 9, and so on. So this is how you can create list comprehensions to write Python codes, for loops, and other things in a very short way, in a shortcut way. Then we have functions. So functions are basically a reusable piece of code. It is started with some syntax, like we define the functions with def is a short for definition. So we are defining a function called z-score expression, which takes two parameters, field and window. So these are the and you call this function with arguments or names or uh, parameters. So why you create functions? When you have a same code that is repeated multiple times, so you can create a function, and then you can just use that function as many times as you want. So it lets you bundle some code under a name so that you can reuse it again and again, and you can call it by its name with parentheses, and in the parentheses you will define the parameters. So for example, we created a function to build a template tsc score expression. So and the default value for window, one of the parameters is 20, and we can create multiple expressions. For example, we are creating with the field close, then volume, then vweb, and we are defining different values of windows as well. So you can also create function to uh, compute the stats for of some numbers. So here numbers is a list of some numbers where we are computing min, max, sum, and sum, then length. Oh, okay, it is basically the average of those numbers. So here we can see the output. Yes. So if we run this function on 3 inputs, we get 3 outputs. So this is one more way to write a code in a way that if you want to reuse it, write it as a function. Then the 12th topic is exception handling. This is very important if you are trying to write a robust code, reliable code that runs even when there are errors, and the errors are or exceptions are handled carefully. So for example, if your code fails, you have observed that the complete script stops, right? And if you don't want that, you can use exception handling. You can wrap your risky code in try except statements so that your programs keeps running. And when your code fails due to bad network, missing file, wrong input, etc., so this technique lets you handle the errors very gracefully. So we will see an example of safe division, right? So to like we have created a function called safe divide that takes two parameters a and b and returns the output of a divided by b. Now if b is 0, is this division possible? No, right? This should throw an error. So we are accepting, like we are catching this error that is called zero division error. It is a predefined error in Python. So we are catching this error in the except block. So if the b is 0, this will accept this error, catch this error, and then print a warning kind divide by 0 is not allowed, and it will return the none value. We can check it here. So when the value of a and b are 10 and 2, it will work properly. And when the value of a is 10 and b is 0, it will throw an error, but it will be handled in this except block. As you can see, the output was none in the second case. So that is also one more important uh, feature of Python to do exception handling. Then you can try and catch multiple errors. For example, there could be a value error, there could be some other exception. So exception is a global class or a umbrella class, not global class, an umbrella class for all types of exceptions or errors. So you can use this whenever you don't know what type of error is going to happen. And then you can run this to see if the value which, like for example, if we are trying to typecast a string which is not a number, then it should throw a value error, right? The conversion is failing when we are trying to convert a string to an integer. So this is an error. And now to now we try with a number, let's say 4. This should work properly, right? Okay, so the error is not occurred. And finally is the statement which will always happen even if there is no error or if there is an error. So this is how try catch or exception handling works. Then the next topic is file read and write. In a lot of cases you will need to write some files. For example, when you are saving some of your fast expressions uh, coming from LLMs or creating some configs. So you will need to save those files, or whenever you are given with some configs, or let's say some uh, list to iterate with or some operator, some data fields, you might have to read them and load it in your Python code. So to do that, let's first create a file of some Python express of these fast expressions. So we have created a list of expressions, and we are creating a text file to save these. So to do this, you will use open function to mention the file's name, and the mode is w. W means write. We are writing a file, and we are opening a file is as f. So for every expression in this expressions list, we are writing it into f. So if we run this, you will see 3 lines through to my expressions.txt. Now if we can see if it is saved, yes, it is there. My expressions is saved, and we can see 3 alpha expressions that are created, right? So this way you can write into files. Then to read files, if I want to read this file, my expressions, you can use the mode as r. The syntax is very much similar. You will use the open function, you will define the path of the file, and the variable where you want to store this uh, file when you open, and the mode will be read mode. And then you will iterate on all the lines in that file, and we will print this. So to do that, we will run this, and you can see we have printed the expressions written in this file. So if I, let's say, change just close to open, and let's see what happens if we are doing something new here. So if I do this, then you can see the change here as well. You can see that the close changed to open. uh, you can see the whole file as string as well. or as a list of line. It depends on your use case. If you want to read the whole file as one string, then you can just use the dot read method. And you want to read uh, all the lines as a list, you can use it as dot read lines method. So if I run this, so you will see the output. So here is a full text, and if I read it as a list, you will get a list of lines right here. Great. So are you with me so far? Is this clear that uh, how to use like basic variables, functions, try catch, basic data structures, etc.? Great. Now let's move on to the next topic, which is JSON. So why I'm focusing on JSON is so the ACE library uses Python to communicate with the Brain APIs, right? And the interaction takes place, or the transfer of data from your code to a Brain platform, or from Brain platform to your code, happens in the form of a JSON. You will send a JSON, you will receive a JSON. So that is why understanding JSON is also very important. Uh, so there is a module called JSON in Python, which helps in converting JSON text to Python dicts and vice versa. So as you can see, we have defined a config containing region, universe, settings, etc. So it is a list, it is a dictionary, as you can see, right? But we can save it as JSON. So I am using json.dumps method to print it as a JSON string. So JSON is a string format, but it contains the information in a structured way inside these curly braces. The syntax is very much similar to Python dictionaries. You can write the JSON strings into files like this, as I just showed. We can just use JSON dump to write our JSON string into a file, or you can also load the JSON files using this JSON.load method, right? So let's try to run this. Here is the printed JSON. So as you can see, the pretty print of JSON is like this. So pretty print is done using JSON.dumps method with indent equal to 2. And then we have saved a file alpha config. Let's see if there's a file saved. So yes, there is a file saved called alpha config.json, which contains these values. And then we can also read this file and print the uh, region and settings from the loaded file. So this is how we can work with JSONs. And it is also very important for you, because when you will work with LLMs, you will send the input or the payload in JSON format, and the model's output will also come in the JSON format. So you should know how to read JSON, write JSON, and so on. So this will be very helpful in like while you will be working with any of the APIs. Then the next topic is APIs only. So what is an API? API stands for application programming interface, and why we are using APIs, right? So one API like will let your program talk to another program over network. Usually the network is based on HTTP. You can send a GET request or a POST request and get a response back from the server, and it is typically present as JSON. So to work with APIs, you need a Python library called request. It is already installed in the latest version of Python. If it is not there, you can simply install the request library using pip install request. So to understand the request or API request, so there are key things to understand. First one is the URL, the endpoint at which you are sending your request. Then there is a method uh, like get, post, put, patch, or delete. Get to fetch, a post to create, put or patch to update the data on the server, and delete to remove the data from the server. So these are the methods that you use while sending a request. You also send some headers This is the metadata along with the request. This might contain some tokens or some content type, etc. Then you send some body or parameters. It is an optional thing, but for example, if you want to send some payload like config to simulations API on Brain platform, you need to send it as a JSON format. Then you receive a response from the API. Usually the status code is in, like, there are status codes. You can learn about status codes from here. HTTP status codes. So here you can find a list of status codes and which one means what. So the very basic and mostly used ones are 200. 200 means your request is successfully completed. 4xx or like 401, 404, etc. means the fault or the error as it has is at your end, and 5xx means the error is at server's end. So you can, using APIs, you can talk with other APIs or other programs on the internet. So let's see an example from Brain platform only, where I am trying to fetch all the operators uh, from Brain platform, but using API. You can like build ACE library of your own if you understand this concept well. You can go to Brain platform, see the APIs, which APIs are present there. You can write your own functions to create some custom tools for your research workflow. So one of the examples is to fetch operators from the platform. So here I have created a request session. I am naming it as a Brain session. uh, I am setting a token called, like, from cookie. It is coming from the Brain platform only. I have shown this in the previous sessions as well, that how to do this. So let me show this once again. So here on the Brain platform, you can go to inspect element, then you can go to network tab, and let's say if I want to learn about operators, so let me just make it a little smaller. And if I click on, yeah, network bar and click on operators, so you can see it has called in some API, right? If I extend this, so it has called some API, which we can see here. It has called this API. The URL is this one. The request method is get method, and the status is 200, right? What is the output of this? The response is like this. It contains a JSON object containing the list of all the operators, right? And here is a cookie where you can find this T cookie, which is a token for authentication. So I have copied this into my code, and if I try to run this here, we should get the same output, right? So we have defined our URL, our method to call this API, which is get method, and then we got the response. So the response status code is 200. The type of headers is content type is application JSON, and we got the JSON response as this, right? So this is the JSON response, which contains list of all the operators as we saw on the platform. So you can do it for other APIs as well, for operators. For example, if you want to uh, fetch the examples, so you can click on show more. Then there is one more API called this ABS API for absolute, right? So operator slash ABS. So we can use this as well. If I change my code here, uh, and I change the endpoint operator slash ABS, let's see how the output gets changed. So output has changed. Now it only contains the absolute operator, ABS operator, and which also contains the content and example as well, right? So based on your use case, you can change or play with these APIs. You can fetch a lot of information from the platform. uh, you can process that information in your prompts if you are working with LLMs. So this was some basics about APIs, and you can, like, play with uh, these functions, right? Now, why it is also very important, it because the ACE library, which we will be covering in the next session, makes use of these APIs to like deal with data, fetch or send data on the Brain platform. So for WorldPoint Brain users, the platform exposes REST APIs. The pattern is the same. You can sign into the session, then you can use request.get or request.post against Brain endpoints. One of such endpoints was operators. You can use these endpoints to submit a simulation, to pull the results, and so on. So these functions, some of these functions are already there in the ASLib, so that you don't need to implement it yourself. But if you want some advanced uh, variations on top of that, then you are free to uh, use these techniques to make changes on your own and create a custom automation script of your own. Then some custom top, like some quant relevant extras, like date time library in Python you can use to fetch the date time. Maybe if you are working with alphas and you are saving them, and you are trying different versions of those alpha expressions, you can hash them with using date time as well. So this is just an example. If you want to work with dates, so this is one way. Then there is a library called NumPy. So NumPy is basically a library to work with arrays in a very fast way. So as we saw, like to work with lists, you need to loop on those values in the list. But if you use NumPy arrays, you can like crunch numbers very fast without looping, and you can do it in one step. So NumPy uses vectorized operations. If you want to know more about how NumPy works, you can read the NumPy's documentation. And if I run this, you will see. So if our list contain these price values, then what is the log returns it has computed very in a very efficient way, right? We are not using any loop or anything like that. So it is very fast than the basic operations that we do in Python. So use NumPy if you are working with numbers. uh, if you are working with tables, then you should definitely use pandas data frames. So pandas gives us data frames. It is a tables of data, like rows and columns. So if you are working with tabular data, it is your go-to tool. When you're working with multiple columns, multiple features, or time series data, you should definitely explore data frames. uh, to use these tools, you should install first, like pandas. So to install pandas, you can do pip install pandas. uh, so let's create a data frame example. I created a data frame called date, then close and volume. Then we will print this data frame, and we will try to find the mean and percentage change. And let's see. So we created a data frame like this, if you can see. So these are the dates, then close values and volumes. If you want to see, know the mean close value, you can use the mean method on the close column of the data frame. So this is how you can work with data frames. So yeah, this was mostly about the fundamentals and basics of Python that you will need to get started with ASLib and work on your automation script. Uh, so what are the next steps? So what are the next steps are, you should definitely look into Python tutorials, Python documentations. You should read about the request documentation, request library. You should also get a quick start tutorial on NumPy, Pandas, and other libraries that you want to work with. You should also try your hands on ASLib from Brain platform if you haven't used it yet. It is very, very important to use BrainLib to scale your research. And the most important point, and last but not the least, use AI as much as possible as your assistant, as your tutor, as your guide, like whatever you want to call it. If you don't understand the code part, you can simply go to ChatGPT and ask it how to like implement Python function to fetch all the data fields from Brain operator. Let me show you a quick example. Let's say if I don't know how to code, I will go to ChatGPT. So this is a ChatGPT, but with a different UI. You can assume it is ChatGPT. It is, you can see on the left top. Uh, it is GPT 5.5. So if I ask it, write write a Python function to, uh, let's say, fetch data fields from WorldQuant Brain API, Brain platform, using API. Also explain the code line by line. So if I do this, it will try to uh, create a function which fetch the data fields from a World1 Brain platform. And let's see. And here it is. So it has created a Python script for you. So it is using request library, it is using pandas, and it is using authentication using request.auth. Then it will ask you for some uh, credentials like email, password, etc. to log in into Brain session. Then it will call the data fields API on the Brain platform, right, to get the results, and it will present all the results in the frame, in the pandas data frame. If you want to see the explanation, you can like scroll. uh, so it has imported the request library and so on. It has given you all the steps, so it is a very very easy way to learn. If you are not comfortable with Python or coding, so use LLMs as much as possible to automate your code, to write Python scripts, to implement advanced functions for your research. So like, and these are some practice ideas. You can try reading some raw data CSVs to compute daily returns, prices, etc. Try to use loops over fields, lookbacks, and other parameters to build expressions. Write them to a file, load that file, and try to simulate that file using APIs. So this is a homework for you to try. And if you have any query, you can post them on my email, sarthak.srivastav@worldquant.com. Yeah. So this was all about like basics of Python. So I hope you were able to follow this session. And if I can, yeah, like if there are any questions, please send it to me. Uh, Let me try to answer some of the questions present here. Can I get the recording? Yes, you will get these recordings. These recordings will be uploaded on the forum. So you will get these recordings very soon. So don't worry about that. And like, you should focus on automating your research workflow using Python code, using LLMs, using Jupyter notebooks, and try to do as much simulations as you can, because that is the only possible way to scale up your research. uh, we will share all the content that we are creating, be it Jupyter notebooks or recordings, so it will be present on the platform, so don't worry about that. And I also like request you to send your queries, your suggestions. What are the challenges that you face during your research? So we will try to solve that using LLMs, using AI in some intelligent way than just typical brute forcing. So send your issue, like challenges that you face or queries, whatever, uh, on my email. So yeah, that was all about the Python essentials, Python basics. And I hope that